It's all very well and good, but what do we do with it? Just to make the point about the complexity of crystalline. Oh yeah, this is a point. This is sort of existential. We go along, we live during the day, forgetting that it's all vacuum, if you really want to take a scientific viewpoint. And nobody really wants to address that, but we are mostly space from a scientific point of view. So that's why space conditioning becomes very important. All right, we're going to cover the ways in which this stuff has been applied and how it can be applied. This is Dr. Kratinov. He has 4 of these devices in Moscow, in his clinics in Moscow and Cyprus. He takes them and applies them directly to people. They just do medicine differently in Europe. They have a different approach. They apply them to the body of the patient for maybe 3 times a week for 20 minutes, half hour. He reported a diabetic that went from acute to normal in about 3 weeks to this application. So he's going to write this stuff up. What's really interesting is he was very excited to tell me that this phenomenon that was emerging, where patients were not only being healed medically, but they were coming back and reporting psychological insights about the development of their case, of their illness, which in itself, now if you 60% of medicine, 70% of medicine is psychosomatic, knowledge is very healing within itself, and he's very excited about that. He also has a proposal to study some industrial processing. All right, so you take all this stuff, you have a generator, our generators I just discussed, they generate things empirically, we see what happens, we analyze the situation, we correlate it with user feedback and process feedback, and we develop an expert system, and that applies whether we're talking about psychology or nanoprocessing. And the ability to create the expert systems for those different areas becomes very valuable in itself, and so we have a tool to promote a whole other industry, because obviously we can't create the signatures to cover everybody, you know, ADD and nanotechnology. That's for experts to do. But we can give them the fundamentals. All right, I got to talk about gauge theory. Don't shut down, it's really simple. At the level we're going to do it. All right, gauge theory is just the mathematics that describes the various forces in the standard equation. And this is a standard model of particle physics. This is what governs the world's largest science project, the Hadron Collider. U1 is our normal world, our Newtonian, Pythagorean, Newtonian world. Maxwell equations that governed electromagnetism. This is the stuff that I learned in school anyway. Then you have all this other stuff, bosons, quarks. But the point is that the next level down, if you're going to incorporate an analysis of all these forces, you have to expand your model. And that model is called SU2, if you're looking here, which incorporates a spin and some other forces. Then when they're looking further down, they just talk about an SU3 model, all the way, which is the core color groups, and that goes all the way down to SU6. So when we say gauge state, we're just talking about what level on the standard model that we're operating at. Now the point is that Dr. Tiller devoted a substantial body of his work as an accredited physicist of the National Academy to proving that these devices modulate the SU2 level. What I'm seeing is up here on my workbench. And I'm saying that what I'm seeing is a correlate of what's going on down here. Who else do we know that works at that level? Well, the nanotechnologists. Nanotechnology is, of course, a huge opportunity because the properties change as you get down there. We love gold. We say gold is our noble metal. There's a movie on YouTube where some fellow is reducing the size of it down to nano, and as it does so, it goes through all the colors of the rainbow. It's not gold anymore. So there's all sorts of stuff going on. We can have an effect on all of these processes. What is nanostructure? Nanowires require very precise crystal ordering. Again, that's all empirical stuff that has to be worked out. Super speakers. This is a report of a graphene speaker. Graphene is the hardest material we have now. It's a crystal based on graphite. This guy is doing a speaker just by heating and cooling it, putting it on the front of an iPod and just heating and cooling it and creating a high power speaker. So that's pretty cool. But the problem with nanotechnology is it kills. It's not going anywhere until it gets fixed. if you get down to the end of this article here, and you got to get down to the end of it, everybody's excited about nanotubes. They found that once inside cells, nanotubes accumulate in the cell, cytoplasm, and nucleus where they cause cell death. Oops. People who take this stuff seriously have to figure this out. This is interesting. This is a report saying Canada's tightening their regulations to advance nanotechnology. This one's saying the United States is way behind. So here's a competitive situation based on the safety of nanotechnology to which we can contribute. What happened to AI? We don't have to go too far into this. The basic problem is AI is a failure. One reason is it results from the essential paradox is anything that's totally programmed, you normally don't consider intelligent. So, that's kind of a non-starter right there, and they haven't been able to get out of it. We can contribute to the situation, or at least provide an alternative through our intentional circuitry, which perhaps can capture an intention, learn, and adapt. Talked about quantum communication. Recall that Tiller reported that his entanglement traveled faster through the Earth than above it. Normally on a communication slide, you'd see, a bunch of antennas here and satellites flying above, frying everybody. Our idea is to use the crust of the Earth and save ourselves. Faster, cheaper, cleaner, more accurate. At least it's an alternative, easy to try, easy to figure out. This just came in. This is KBBF. It's a diode, it's a crystal diode, and it happens to have placed the Chinese 15 years ahead of us in superconductor research. They're not giving it away, they're not passing it out, they're not loaning it to anybody because it breaks down as you use it. What it does is takes regular old lasers and converts it into ultraviolet lasers. Why? Because it's a very thin, very high quality laser that allows them to examine superconductors with greater precision. But we're nowhere near this. This opportunity itself is justification for research. Now, a lot of interesting things here, but the last thing I want to touch on is this. This is cool. Correlation between nanosecond X-ray flashes and stick, slip, friction, and peeling tape. That's a fancy way of saying when you pull something off your Scotch tape, when you pull a piece of tape off your Scotch roll at your desk, you generate X-rays. They've measured it. They're studying the X-rays being generated off this slight... Now tape, think about tape. It's all crystalline-based. You pull it off, you're imparting a physical impulse to it, and they're measuring, as a matter of science, X-rays. So, if you can get X-rays from pulling Scotch tape off of a reel, you can get X-rays by powering these devices with ambient electromagnetism.